What's up, my chemistry students? And today we are talking about the combined gas law. Alright, first before we do this, I would like to show you this quick little video, and I'd like you to have this discussion tomorrow of why do you think the water rises, and what does it have to do with the gas law? Before we get to our example, we need to define STP. STP is the standard temperature and pressure. And when we're looking at this, we are now looking at gases. So STP for gases, standard temperature and pressure, happens at 1 atmosphere. Now, it's defined at 1 atmosphere, so I could throw out as many sig figs as I want. I put 4, so 1.000 ATMs. And 273.15 Kelvin, so exactly at 0 degrees Celsius. Okay. So we want to keep those standard conditions like in a laboratory setting. Okay, so here's our example. We've got the combined gas law at the top. Just remember that P stands for pressure, V stands for volume, T stands for temperature, and then the difference between the 1 and the 2 are 1 is the first set of conditions, 2 are the second set of conditions. And the question, a gas occupies 7.84 cubic centimeters. That is a unit of volume, any cubic unit of volume, so that's V1. At 71.8 kilopascals, so that's P1. And 25 degrees Celsius, that's T1. But I'm going to go ahead and add 273.15, round to the correct number of sig figs to get 298 Kelvin. Alright, so then we're find its volume at STP. So that means that volume is unknown. And now we need a standard pressure. So standard pressure would be 1 atmosphere. Now I don't want to really leave it in atmospheres because the pressure given to me is in kilopascals. It's much easier to change this 1 atmosphere into kilopascals than to convert the kilopascals into atmospheres, but you can do it either way as long as you have the same units. Okay, so I went ahead and said, well, I know the definition of an atmosphere is 101.3 kPa, so therefore there is my units of pressure in terms of kPa. That's standard pressure. Then we have standard temperature, which is 0 degrees Celsius, or 273.15 in Kelvin. Here's our combined gas law equation. Remember I said when you have these two fractions equal to each other that I want you to flatten out the equation. So your first step would be to look at the equation and just cross multiply. So you would skip this part, but just go straight to cross multiplying and flattening it out, and you would write this. Okay, so that's P1V1 times T2 equals P2 T2 V2 times T1. Alright, so then we need to know which one are we solving for. We're solving for V2, okay, which means I need to move over P2 and T1. So then I'm going to divide both sides by P2 and T1, which cancels the P2 and the T1 on the other side. Then I can just plug everything in that I've listed over there into the equation. V2 is equal to all of that. So I just plug stuff in, and there we go. I'm just being very careful. This is where you'll mess up. You'll rearrange perfectly, but you'll plug stuff into the wrong spot. So be careful where it says P1 or V1, and don't plug the wrong pressure in. Okay. We'll check to see which units cancel, and that's kPAs and kelvins. Oh, that's slightly off, but Kelvin cancels. All right, so then the units left are cubic centimeters, And if I do the math, I get 5.09 cubic centimeters. That's to 3 significant figures. That is my final answer, and this shouldn't be any harder than doing the simple gas laws. So hopefully you found that easy. Bring questions on this one to class.